Welcome to the Apalachicola National Estuarine Research Reserve. This is an absolutely magical place, as you'll see as you tour this area with us today. You will meet the research staff, the education staff, and the upland management staff today. Learn what we do, what the Apalachicola Research Reserve is all about, and we're pleased to show it to you. The Apalachicola Reserve is almost 250,000 acres. However, it's part of a drainage basin that drains 19,800 square miles. We consider that this estuarine system starts about 80 miles north of the city of Atlanta. It includes many habitats that are necessary for estuarine productivity: the floodplain, the river, the marshes, the bay itself, and the barrier islands. This system is so nearly perfect, just the way Ma Nature put her here, that she is one of, if not the most productive estuarine systems in the northern hemisphere. An estuary is nothing more than where saltwater and freshwater meet and mix. The role the barrier islands play is to slow that mixing. This nutrient-laden freshwater coming down the river out of the floodplains is held by the barrier islands, slows the mixing so the nutrients are incorporated into the estuarine food web, and that's what makes Apalachicola Bay so magical and so productive. Our seafood harvest in Apalachicola Bay is a $14 to $16 million a year industry, dockside value. And if we use a fudge factor that the economists call a multiplier effect, the worth of a product from the time it's made till somebody does something with it, in our case from the time it comes out of the bay till somebody consumes it, realizing that every time it changed hands it generated more money, then the economic worth of this small estuarine system is a $70 to $80 million a year industry. Now, if you're not yet impressed, although there are a lot of zeros in $80 million, if you're not yet impressed, you are absolutely right on target. Those numbers don't come close to telling the economic importance of Apalachicola Bay. In the open Gulf of Mexico, 95% of all species harvested commercially and 85% of all species harvested recreationally have to spend a portion of their life cycle in an estuarine system. Blue crabs, for example, migrate as much as 300 miles to spawn in Apalachicola Bay. They spend their larval and juvenile stages in our marshes, then they scatter over the Gulf. So do shrimp, so do finfish. They're harvested somewhere else, landed somewhere else, and reflected in somebody else's dockside value. But the product wouldn't be there if Apalachicola Bay weren't where she is and in the relatively pristine, productive condition she's in.
Our main goals for our Apalachicola program here are to help people understand and be aware of the situations in our estuary, and also to learn how they can take action to try to protect our Apalachicola Bay.
We're going to have you take some different measurements. Now we're going to one station, but at that one station...
Well, we're having a small group of students in a summer program from Carabel come over with us, and we're going to take them out on the vessel and collect and identify some species of animals that live in our bay habitat.
Oh.
You want to release him? Or?
Yeah, I want to let him go. And that's that was a hardhead catfish. This guy is too. Michael, can you hold that and let's see what we got here.
I think it helps give them an understanding of some of the needs of the animals that live in the estuary.
But if you
trying to bite me? No.
You can see that. It's a bay whiff, which is a type of flounder. And we can touch him. You can see both eyes are on the top. And when this fish was small, when he was planktonic in his larval stage, he swam upright and had an eye on each side of his head. Then when he grew, got a little bigger, that eye actually migrates. It moves around his head, ends up on the top, and his body sort of conforms to lay on its side. So on that underside, there's no eye, no camouflage. So this guy's called a bay whiff. These aren't the type that we eat. These don't grow very large. Let's look at him, and then we're going to let him go.
They come away with just an amazement of what's out there.
What are you looking at? Oh yeah, check him out. He's not even going under. Little bitty alligator right here. We have people coming down here asking to see alligators every day, and usually he's not going down either, is he?
Just to pique somebody's interest is a very important part, I think, of helping them desire to protect something.
Looks like a decoy or something. Pick it up. Does it look like it's closed? Okay, get it over our bucket here.
We'll also be doing some water sampling so they can compare some of the water quality parameters that are important to the species that live here.
Okay, so saltier on the top than on the bottom. What did you guys get? Uh-huh.
One of the things that I think that's really important is environmental education, and that's one of the facets of our program. That we try to expose them to their area, allow them to learn about their communities and what are the resources that are available to them, why it's important that we take care of our bay.
Can you feel gritty material in there, or does it feel really slick and smooth? Pretty gritty, isn't it? Feels like sand on the beach, kind of. Yeah, that tells us that we're not very far out in the estuary from the mouth of the river, because as the river is carrying its load of sediment from the river out into the estuary, the water current gradually slows down, and the heavier particles, which are the larger grains of sand, settle out first. The economy in this county is based significantly on the seafood industry, so we're taking many species from the estuary for human consumption. And many jobs depend on the estuary, not just the people that are directly harvesting fish and shellfish in this area, but also the people that are working in the processing facilities, driving the trucks. Many different industries depend on it. There aren't many places like this left in Florida or in the country. This is really a nice natural estuarine system that is really impacted not very heavily by humans at this point. And we need them to understand things they can do to protect and preserve it for their future generations. Yeah, dig in there.
We're on a particular creek. It's called Cache Creek. And the reason we stopped here is because this is one of the major drainages of Tatesville State Forest, a huge area of land in public ownership. It's managed by the Florida Division of Forestry. And the issue here is land that's in public ownership and in fairly natural condition is one of the major reasons that Apalachicola Bay will stay in good condition, is because of the quality of the land that surrounds it. When it rains, the runoff from the rain has to go somewhere. And in this particular instance, this particular body of water flows directly into East Bay, which is arguably the most productive portion of Apalachicola Bay. That will directly affect the commercial fisheries there and directly affect the water quality for all of Apalachicola Bay. Anything that washes from this system runs out directly into Apalachicola Bay. If we had houses here and we had landscape lawns here, or we had paved roads here, we'd be washing petroleum-based chemicals back into the water. We'd be washing pesticides back into the water, fertilizers back into the water, and anything else that's associated with development, be it commercial or residential development. And that's one of the nice things about the Apalachicola Bay area. Literally all of the land that you can see from this vantage point is in public ownership. These particular types of lands are subject to burning, prescribed burning. The prescribed fires go a long way to mitigating the opportunity for those horrendous wildfires. A prescribed fire or frequent fire keeps the fuels down to a level where they're more manageable. Had there been no one here 500 years ago, this area probably would have burned a lot more frequently than it does today. If it's fire excluded for years and years, the woody plants or the larger plants tend to take over and shade out the herbaceous understories. This is saw palmetto, real common throughout Florida. One of the things that happens in Florida natural communities, if they haven't been burned on a frequent basis, is this particular type of a plant will take over the understory or the ground cover beneath canopies of pine trees. And after these plants get thick and dense, they shade. They obviously have a lot of shade capacity. They shade everything out underneath them, and you lose all that diversity base on the ground in forested areas. And the effect of that is when a wildfire does happen in that area, all those large plants that have been shading out the smaller plants are removed, the smaller plants aren't there, and you've opened the area up for soil erosion. Then if you get a large rain event immediately following that type of a wildfire, that is a wildfire in an area that's been fire excluded for so long, soil erosion starts to take place. That directly affects the water quality in East Bay.
This is the East Bay portion of the Apalachicola Bay. This is the most important nursery ground in all of Apalachicola Bay.
90% of the oysters harvested in the state of Florida come from this bay, and 10% nationally. In other words, 10% of the oysters harvested nationally across the United States come from Apalachicola Bay. They harvest up to 6 million pounds of oyster meat a year. That's minus the shell. That doesn't include the shell, so that's a lot of oysters.
That's delicious.
We're not totally pristine, but we are one of the more pristine estuaries in the system. We have a lot of concerns with regard to how that's going to change in the future because of things like pollution coming down the river, reduced river flow, and local development. We're starting to see a lot more development, even though we're in the panhandle of Florida where there's less people. We're starting to see more houses, more tourism, and that type of thing. And we're not necessarily against that, but we don't want to trade our seafood industry and our natural resources for a tourism economy. We'd like to see both for the good of the area. We've been monitoring water quality in Apalachicola Bay since 1992. And we have continuous data from data loggers deployed in the bay. So we're interested in what's going on in the water, what's causing the changes in those parameters. And in particular, in the last 10 years, there's been a big program going on with regard to the state of Florida, Georgia, and Alabama suing each other on how much water comes down the Apalachicola River. There's a lot of negotiations going on. So we started this project back when the discussions first started about holding more water back in Georgia. So what we're interested in is, what's that going to do to Apalachicola Bay? Apalachicola Bay is one of the most productive bays in the United States, if not in the world. Oysters, shrimp, crabs, fish. And so the concern is, if we get changes in the bay related to fresh water, we get increasing salinity, what's that going to do to the system? This is Kim Miller. She is a biologist here at the reserve, and she's in charge of our data logger sampling program. And what she's doing actually is calibrating the data logger. These measure salinity, temperature, dissolved oxygen, turbidity. That means how much material's in the water. We program it. In other words, she's going to tell it how often to sample. She'll be telling it every 30 minutes this machine will turn on, and it will take measurements of those parameters. And she'll tell it how long to continue measuring. She'll set it up to measure 2 or 3 weeks. And what we do with the data loggers is, every 2 weeks we go out. We have 4 data loggers set out in the bay at different locations. Okay, let me turn off the engine. What we do is, every 2 weeks we have to go out to each site, the 4 sites we have in the bay, and change the data loggers out because we have fouling problems. There are critters and algae and sediment that will settle on the probes, and then you don't get good data anymore. So we'll pull these out. There's probes behind this screen here, and each probe measures a different parameter. And then inside here, it's a little computer chip, and it saves all the data. And the computer chip inside tells the instrument when to turn off, when to collect data, and how long to collect the data. And then when we take it into the lab and connect it to a computer, we actually just take all the data. It downloads all the data into the big computer in the lab. Then we'll make some graphs of the data and do some analysis on what's been going on. This is a graph of 2 weeks worth of data from June 7th through June 19th. You can see salinity, temperature, dissolved oxygen. You can see the changes. This is every 30 minutes. You can see here, this is depth. This is showing you the tides. So the tide, this is low tide, high tide, low tide, high tide, and it shows you the tides over that 2-week period. And if you look at some of these other signals with the temperature and the salinity that dissolves oxygen, you can actually see how they relate to the tides. So as the water goes up and down, it affects the salinity, and it affects the dissolved oxygen and the turbidity sometimes, because you may have salt water on the bottom and fresh water on the top. As the tide comes in and out, that salt water may go higher in the water, or if the wind blows, it may mix it all up and it will change these parameters. And the organisms that live out there have to be able to survive those changes. And that's what we're trying to determine. We're on St. George Island, part of the Apalachicola Reserve. This is a sea turtle track. What you're seeing is probably a loggerhead track, judging by the width and the way the flipper marks are. You're seeing the tracks of the turtle as it left the water, probably last night, crawled up on the beach, laid a nest hopefully, which we'll find out in a minute, and then crawled back into the water. We patrol this beach. This is Bruce Dry beside me, who runs our volunteer sea turtle monitoring program on this island. He has 10 to 15 volunteers out here every morning walking the beach. They each walk a mile or two stretch, and they look for the sea turtle nests, check them, mark them, make some measurements, keep track of them, and then come back after the nests have hatched to see how successful the turtles were. Sometimes it's obvious the turtle just came up on the beach, turned around and went back. Sometimes it makes a body, what we call a body pit. If it makes a body pit, usually that means there's eggs there, but not always. Something could have disturbed the turtle. So what we do is we verify the presence of eggs before we mark the nest to see if it's really a nest or the turtle just came up, turned around, and went back in. So what Bruce is doing is he's looking for soft spots in the sand. That's how he can find the eggs, because the turtle, once it dug a vase-like pit, when it covers it up, that's a little softer area. So judging from how his hands are moving, I think he found some eggs. Did you find some eggs, Bruce?
Yeah, I found eggs.
Okay, so this is a nest, a loggerhead sea turtle nest. It'll take anywhere from 55 to 70 days for the baby sea turtle to hatch, and there's typically anywhere from 70 to about 150 eggs in a nest.
Would you like to see? Come on over.
These loggerhead eggs are normally the size of a ping pong ball, as you can see, and we'll leave this loggerhead nest in place here, and these eggs will take about 55 to 65 days to incubate, and they'll remain in place, and they'll probably hatch out at night at the most inconvenient hour, so no one will see it. Turtles instinctively do things at the quietest hours of the night, so there's less predators. But this nest will probably incubate real well here in this dune area. It's high and dry, it's well away from the water and possibly high tides, so this nest will probably incubate completely safe here for 55 or 60 days.
Do they lay eggs all year round?
No, they only lay eggs between May and September.
How long did it take her to do this?
This turtle probably took, now you got to consider the distance from the water and how slow they are on land. The turtle probably took 45 minutes to an hour and a half to do this nest. And then she goes back and never looks back, never comes up here to help her young out. They're completely on their own from now on.
How large is she?
This turtle, judging from the crawl, which is about 32 inches wide, this turtle probably weighed as much as 300 pounds and had a shell length of maybe 36 inches long by 32 inches wide. A large turtle, as big as a coffee table.
What brought you guys out here? Somebody reported or just see the track?
We walk the beach daily as volunteers searching for turtle nests and turtle crawls. And once we find them, we mark them. You'll see me mark them with a stake and 4 wire flags, similar to that nest that's marked right there. And then we'll monitor this daily until it incubates. And when it incubates, then we'll know exactly how long it took for these turtle eggs to hatch out.
So Bruce has located the eggs. What we'll do is he'll cover them up as soon as possible so we don't change the temperature any of the nest. Then he'll mark it and keep track of it for the next 2 months. Then they'll come back. Now that he's found the eggs, it'll be a lot easier to find when he comes back in 2 months.
Turtles, as in most things in nature, have a cycle. And we are beginning to notice these cycles now. We haven't been studying sea turtles long enough to have a real good handle on being able to tell people about the population yet. But we do know that our population on the island can range as high as 300 nests and as low as 50. So that's a wide range. But a lot of that has to do with how good we, as observers, do our job. Sometimes I'm concerned about the objects people leave on the beach because that disturbs turtles when they come up to nest, and it can trap hatchlings en route to the ocean. So we're concerned about the items that are left on the beach. Catamarans, floats, beach chairs, canopies, things like that. But I try not to get mad at the visitors.
We are looking at some of the salt marshes that fringe the Apalachicola Research Reserve. These marshes, once considered wastelands, are now known to be among the most productive habitats on the face of the earth. They are more productive than tropical rainforest, more productive than coral reefs. They are up to 7 times as productive as our cultivated wheat fields, complete with fertilizer, complete with irrigation, a totally renewable resource. All we have to do is understand how important they are to estuarine productivity and protect these kind of systems. During spring, summer, and fall, every handful of water you pick up in these marshes is literally teeming with life. That's the next year's seafood, or the next year's seafood, or at least the food that produces the seafood. Without these marshes, estuarine systems wouldn't be very productive. Without the estuarine systems, the Gulf of Mexico wouldn't be very productive, because it's all functionally tied together. All we have to do is understand these functional relationships, and we can maintain this incredible productivity for many future generations. I sincerely hope you have enjoyed your tour of the Apalachicola National Estuarine Research Reserve, and you have a personal invitation from me to come and visit it yourself.